next keynote speaker, it gives me a great pride to introduce Dr. Anandavalli, the Director of CSIR, Structural Engineering Research Center, Chennai, a distinguished name in the field of civil and structural engineering. Over the course of her illustrious career, Dr. Anandavalli has made pioneering contributions to structural health monitoring, disaster mitigation, and sustainable infrastructure development, areas that are critical to India's growth and resilience. At the helm of our CSIR cell, Dr. Anandavalli has spearheaded cutting-edge initiatives aimed at addressing the pressing challenges of infrastructure, durability, and sustainability. She has been pivotal in promoting partnerships between academic institutions, industry, and government agencies, ensuring research is not confined to laboratories but transferred into practical real-world solutions. Her contributions extend far beyond technical innovation. She is a passionate advocate for science, education, and outreach, engaging with initiatives like Jigyasa, Atal Tinkering Labs, and Open Day programs, which bring science closer to students and kindle curiosity among the younger generation. Her work has been recognized with prestigious honors, including John C. Common Prize and Sir Arthur Cotton Memorial Prize, awarded by institutions of engineers in India. Additionally, she has served as a Senate member of Bharatiya University, a visionary leader, accomplished engineer, and dedicated Dr. Anandavalli exemplifies the blend of technical excellence and human values that define transformative leadership in science and engineering. I hereby welcome you, ma'am, to come share your wisdom on building India, opportunities and competencies near to India.
Vanakkam and Namaskar. So, Pini in my selvam vilevu imbam emam ani ember naatrukke ivaindum. So, just now we were listening to the fifth one, that is Nalla Kaval, so security. So, after that inspiring speech, maybe my thing will not be that much catchy to all of you. So, with that, I thank the organizers first for giving me the opportunity to speak over here, and also for the nice introduction. So I'll be talking on the opportunities, how we are going to build our India. So my presentation goes to say a small introduction on this topic, structural engineering, followed by what CSIR is CRC, what we do for shaping the infrastructure since 1965 in the same city, and computer-aided analysis and design. So what are the current and future trends? So that and also what is the futuristic infrastructure? What is the need, challenge, and features which we expect in the futuristic, and how we have to equip ourselves for that. And with concluding remarks. So happy Engineers Day to each one of you. September 15th, we have celebrated our Engineers Day in memory of Sir Mokshagundam Vishveshwaraya. We should all feel pride that we are civil engineers, have built the nation, and it is in memory of a great civil engineer that this day is being celebrated. One thing, what I would highlight upon, and his whole journey, if you read, is very interesting. One thing is to give real service is not just money, but it cannot be measured with money. So you should add something which makes difference in each one's life. That is what he was living in his 1 years of life. And when we see structural engineering, I can see it as a Panchakruta. So we address the basic necessity of one of the basic necessity of human, the shelter, and the range is not limited to buildings, but also energy to environment, materials to infrastructure, sensors to monitoring. So I see the sky, which as a space, which represents space, as a shelter, building and structure, with mobility, which is represented by air, because it represents motion, bridges, railways, ports, and the third one is fire, where it represents energy and we have to monitor unwanted events. We have to be very vigilant in this case. And also the fourth one is water, which represents protection. So we should have mitigate whatever hazards. And the fifth one is earth. Earth is whatever we it recycles itself. So circular economy is what we should bring in all of our design and whatever we are doing, not only in terms of design but also beyond that. So, and also if you see where CAD, computer aided design, each step it is there. The first step, we need a good configuration for the structures, so which ensures also the strength. So which again CAD is required, so you can visualize it. The second level is the stability, load calculation analysis, again CAD helps. And the third one, if you come, you should have detailing, design, materials, all these buildability and all these can be ensured, and also we can use CAD to bring out all these around. And the fourth one is after till construction we all take care, but beyond construction, monitoring and maintenance is equally important, as we all know, but sometimes we don't take care of it. So there is again for monitoring how we can use CAD, and so if we adopt all these steps, we are ensuring the safety and can build safe and sustainable structures. So with all these uncertainties, say the materials, the properties can only be estimated, because we estimate in a small specimen and their behavior in the actual structure is little different from what we analyze the estimate the properties. And also the structures which we analyze is always approximate, and the forces it's not accurately known. With all these uncertainties, it is our responsibility that we have to have a safe structure. So what is CSIR SERC is all about? Structural Engineering Research Center. So with one spirit for 60 years, we have been working on 4 different verticals. It is one of the 37 CSIR laboratories which is across the country, and the CSIR SERC is located in Chennai, Taramani, and we work on 4 different verticals. One is only basic and applied research, where we try to understand the science behind each and every aspect of it, and then use this knowledge to do the industrial research and consultancy, while we also contribute to the societal development as well as to the strategic sector. And some of the legacy, what I would like to highlight upon, many of you may not be aware. So the India's first fly ash building, where 30 to 40% of cement replacement with fly ash was demonstrated in our campus, and this building is still existing in our campus. A test as a case, and after which the blended cements came into BIS code. And the pre-stressed concrete sleeper, that is a technology from ACRC. Way back, this is the range from 65 to 84, and cold deform bars, that is again a technology which is from ACRC. And prefabrication, those years where people never thought of prefabrication, ACRC has demonstrated this colony in Besant Nagar. It was constructed using prefabrication. So these are all different other different aspects where ACRC's contribution is there. And between the next 15 years, you can see the other aspects, like we were also in Antarctica, Maitri Research Station, as well as some of the industrial things and societal things, say cyclone shelters. We have designed the cyclone shelter, implemented them in the Odisha coast, and we have also taken care of the TG foundation, vibration issues and other things. And coming to the latest years, the interdisciplinary research, that is what our focus is there, more on the structural health monitoring and also development of different sustainable materials. So recently we are focusing ourselves on additionally on renewable energy infrastructure and as well as offshore structures. So these are all different 6 thrust areas which we focus, and also there are 10 laboratories which address all these aspects. So we also have a Journal of Structural Engineering, which is from 1973. It is being every quarter we have this release of this, and also we run a program through our academy ACSIR, Engineering of Structures. We have dual degree as well as PhD, industry sponsored PhD also. So with that introduction about ACRC and what ACRC is all about, I would like to come to this topic on building India, where design and innovating India. That is what we are going to talk about. So in that verse, if I see which this can happen is, we have got tools such as finite element analysis, computer-aided design, artificial intelligence, machine learning, and also new technologies that could speed up and also the quality control can be done. And our focus is we need on advanced materials for sustainable structures, so analysis and design from computer-aided to AI-enabled, and structural health monitoring for monitoring and maintenance, disaster mitigation. As we know, natural hazard is one side, the other one is on the man-made hazards also, and renewable energy infrastructure and offshore structure. These are all the focus areas which we need to see. And the challenge is, if I had to see what is there, we need trained manpower. Manpower is our strength, HR is our strength, but skilling them in different aspects, BIM, CAD, all these are required. And adaptation of new material system or technology by the industry, there is still we need to enhance that. This will be enabled when policies are in place. So we need to have some policies where the new technologies can come into place, which can speed up, both speeding up as well as quality can be improved. And circular infrastructure, where we have to see the life cycle analysis, deconstruction plan, all these has to be taken care, and when you, the young generation have to be aware of it, and we should also have the methodologies how this can be done. And opportunities, we have a lot of different institutions, we can co-work together, and the basic buildings block I see it as trust. That is where we have to build this co-working, so we can, each one's strength we can co-work and then bring out more impactfulness. And coming to other GOI initiatives, if you see, there are a lot of opportunities where we can go for this building India as well as innovating India. As all of us know, Atmanirbhar Bharat, Pradhan Mantri Awas Yojana, smart cities, and Swachh Bharat mission. So computer-aided design, it has evolved from simple drafting. Then initially people thought CAD is for drafting, now it is digital engineering. And also it is 3D, interactive, intelligent, cooperative and data-driven, and it connects imagination with innovation. Civil engineering is all about imagination. First is we have to imagine things, then we can put it in place. So imagination and innovation are part of civil engineers, and so we have said CAD can be used as a parametric modeling. So a new kind of system, a lot of parametric studies can be done, and smart adaptive models can be created, and it can be integrated simulations can be there, CAD plus FPA or CFD, computational fluid dynamics, and also real-time collaboration. So we can have a part of it as a physical infrastructure and virtual infrastructure, and we can have a collaborative real-time simulations, and also generative designs where AI-driven options are there. CAD plus BIM, the digital twins for infrastructure can also be explored. So these are some of the things which we are doing. Renewable energy infrastructure, we have tried to create the design right from scratch, not only the substructure design, the floating substructure, but also the aerodynamic modeling, hydrodynamic modeling, stability, fatigue related thing, and structural health monitoring. All these aspects as a holistic approach to for this, including structural health monitoring. That's what we try to do through this. Like we have worked on it, and we are trying to take up a pilot plan where this can be implemented. So it requires a lot of analysis, low fidelity to high fidelity analysis, as well as a lot of CFD simulations, and also experimental things. So all together. It's not one vertical, it has to be an integrated approach so that our whatever we are bringing in will be very impactful. Right now, this technology is being imported, the design is being imported, and we have started working on it, and we have reached to such a level that we would like to do the pilots. So another major trust area where our people are working is on structural health monitoring and maintenance. So where we need the multidisciplinary approach, not only with respect to civil engineering maintenance, but also instrumentation as well as sensor development. We, along with other CSIR labs, we are involved in indigenous sensors and bridges and infrastructure where we can explore the capacity enhancement, because many of the bridges are very old bridges, and the safety assessment, both we can do, and pipeline structures where the leak detection is very important, where we can use the latest guided wave propagation techniques, acoustics. So all these lab scale we do simulation, then we go to the field. And also many of the structures doesn't have a baseline data, so we need a baseline free development where we can localization of defect or image can be done. These are some of the areas where our people are working. And we started with how to measure the in situ stress assessment with various port repanning as well as flat jet technique. These are all experimental things which we try to initially do it. Then SHM analogy, as we all know, like a doctor, we go to the health checkup to the doctor, medical doctor, similarly the HSM engineer, when we monitor the condition, uses sensors, and also we can assess the excessive stress and correct the situation. So each step we need a simulation or a kind of check which can be done only through simulations. So a lot of CAD is required, and these are several sensors which we will be using at acceleration, strain, displacement. So many of these can be simulated. Like initially we can model it and get an idea of it, and we can go to the site and implement and verify the thing and go for it. So this is the map which shows where our people have traveled across India for various railway bridges, and we were also involved in the expansion of old Palmer Bridge, and in the new Palmer Bridge also we are involved in the SHM. So this is again how capacity augmentation. Again, this device is like a proposed device for mitigation of longitudinal force, which was implemented in 2 bridges. Again, these were simulated. So after simulation, after it was verified, then we have gone for trials, and after the trials were there, we are coming out with the guidelines which will help the railways to implement such mitigation devices across various bridges. And this particular slide will show how simulation has helped us to design a new strategy, retrofitting strategy. So normally CAD is thought of for only development. This is also for retrofitting, how it has been helpful. So this is a very old bridge, 160 years old railway bridge, arch bridge, which there were some issues. So we had come out with a new strategy how to retrofit it. So before going to that, we have simulated in the using the finite element analysis, and then we have also implemented the retrofitting strategy in the numerical and found out its efficacy, and then we have got implemented and the structure is restored and it is being used. So both ways it has helped us. One is the traffic has not been stopped, so continuous traffic was there, and cost has been saved. By construction of new bridge, we would have spent a lot of money, and the whole heritage is being still preserved. So then this is on the railway bridge vertical lift type navigational span for Palmer Bridge, new Palmer Bridge, and we are involved in the instrumentation of load testing as well as real-time health monitoring system. So before going to such a thing, we do all the things at this laboratory scale as well as in the numerical implementation. Then we go to the site to implement them. So it becomes very effective. And also post-processing, again that requires a lot of data analysis. And AI also comes in handy. So all these put together, we could give a very good solutions. So this is again for dam structures, how these have been useful. So different kind of strategy we have to adopt and how this has helped us. Maybe it is seen as experimental thing, but behind this we have a lot of numerical as well as lab scale studies, after which we take it to the site. And some of the future directions in this is we need low cost and robust sensors, as well as we need physics-based models and computational efficient. They have to be, and baseline free methods, and also IIoT for monitoring large number of bridges. So these are all some of the requirements of SHM, and many of the young engineers can get equipped, so a lot of scope is there. And digital twin is for predictive assessment. That is what tomorrow's SHM is, and it can be a game changer technology, and a lot of work is being carried out in this area, and how the changes can be predicted, and how it can be integrated between the physical and the virtual structure. So coming to the futuristic infrastructure, so how to forecast the future? We need imagination plus the knowledge of cutting-edge technology. And what we need to see is, in future we need human life, technology as well as nature has to coexist in harmony. That is what is required. And what are all the challenges? As we all know, growing population, rapid urbanization, resource scarcity, environmental degradation. I will not go into details of it, everyone is aware of it. And technological advancement, how we are adapting to the technological advancement, and also climate change and disaster resilience, how we have to change our analysis methods, how to include this climate change, all these we have to think about. So coming to the cities of the futures, we have, it has to be sustainable. Sustainability is the first thing, then resilient, and also it should be adaptable to the societal needs, and inclusive. So it has to be inclusive. So a kind of development should not leave a sector of people or some age group. It should be very much inclusive. So it is, and also it should be integrated with the environment. These are the things which we need to keep in mind when we think of the cities of future. And some of the enablers or components is artificial intelligence will become part of it, Internet of Things. So renewable energy, as we know, there is a lot of trust in this area, and robotics. These are all different areas where many of the youngsters have to focus, so that building India is again how we are capacity building in these different areas. We need to build capacity. So principles, as we see, the futuristic sustainability, innovation and inclusive design. While in future we list what are all the challenges, traffic congestion, energy shortage, these are all these things we need to address. And some of the features we have already described, these are all is required in the futuristic infrastructure. So if I segment it, there are 9 different areas. We can see smart cities and digital integration, and transportation sector, and net zero building. So these are all different aspects which we need to take care in our futuristic infrastructure, and we have to enable ourselves to handle all these things. So we move towards floating and vertical cities. Some of the things are happening. So for example, hyper-connected autonomous, IIT Madras is coming out with some of the things, and sustainable net zero buildings, we have also been working on carbon capture and other things. So water management, resilience, circular economy, again, how to use the recycled aggregator. All these are, some of the things are happening, and focus will be more on the future. So digital integration, smart cities. So what are all the requirements I see? We need to improve the efficiency as well as sustainability and quality of life. That is the need of the above. And what the different aspects, if I see digital twins, is one where we can use this to simulate the changes. So before we put it in practice, we can simulate these changes using the digital twins. And also new policies before we bring into implementation, we can see how it affects are there by simulation. And natural disasters, some of the resilient technologies, we can also adopt this digital twins so that we can come up with a very effective technologies. And infrastructure management, as we need to address all these things, not only traffic flow, energy distribution, waste collection, water management. These are a few of the things which we need to take care. And continuing to that, we need IoT connected systems. So this is some of the things, activities in some of the building communities. It is already there. So as a city, how we have to go, and also how it will be interactive between the residents and urban environment. And augmented reality is where we can have a lot of these interactions simulated in other. So these are some of the activities that is being undertaken, and a lot of scope is there for future. And coming to the transportation sector, if you see, we need underground and aerial transport. Now air taxis are available, so more of them will come, and drones to transport not men but materials. Now medicines are being transported, maybe fertilizers are being used in aerial routes. So in future we may have so many other things where densely populated area this can be taken care. And also mobility as a service. So some of the things is happening. So we are also responsible, like we have to take care of these things instead of having our own car, single car. It can be integrated things and sharing, and also optimizing. These are different aspects which we have. And also quantum computing will be coming in hand in these cases, and AI governance. So as we see some of the aspects, so we need our engineers have to become digital collaborators, not just drafters. So initially we thought CAD is drafting, now it has to go towards digital collaboration. So more of automation, so repetitive work can be reduced, and new skills are required. So AI tools, data integration, virtual reality, augmented reality, these are all the new skills which our engineers have to get trained. And also we should support sustainable and circular economy goals. That we should keep in our mind. So coming to the future trends, as we highlight all these things, it's very clear that AI and machine learning will be there for predictive design, intelligence, and also visual reality and augmented, so where we can have immersive walkthroughs. Already some of the developments are there. We can see many of the promoters, they have this already in hand, like immersive walkthrough, where we can see how our building looks like. And digital twins and IoT, it will become imperative, so we have to have this. And sustainability tools. So every step has to have this carbon footprint, and how it has to be done. We should have a SOP kind of thing, or a guidelines, which we have to bring it out. And quantum computing, so quantum CAD, where we'll have complex designs, real-time optimization can be done. So quantum computing will be used. So some of the aspects which we have talked earlier on sustainable energy, net zero. So renewable energy is one option. We have to adopt to that, and also generate as much as we consume, and also optimize our energy use. These are all the basics for the carbon neutral cities. And climate resilient design. So different weather conditions, we have to have buildings that can float in case of floods. Some of the developments are already happening. I think one of the IITs, they have come up with a design where the building, the houses can float. And also we have come out with climate resilient design for 4 different regions, for dry region, extremely cold regions from CSIR. And some of the heat resilient urban designs, all these we have to look into. And as far as we move to globalization, again we have to go for localization. So decentralized energy grids, locally produced energy, renewable energy, as well as we have to adopt the local materials, how we can use it in our construction, and also reduce the transmission and disruption loss in case of renewable energy if we have decentralized energy grids. And also carbon capturing infrastructure. These some roads can capture, or we can store buildings. Maybe the columns can be made where it can capture the carbon and store the carbon dioxide. And also some other aspects where carbon capturing infrastructure can be thought of. So some of the things put in thinking, and some of the things which is available in the nature. So coming to the waste water management, this is another. We have to look into our own system. Say, for example, we have got the best water management system in Tiruchi, where Kalana is the best thing, which is existing more than thousands of years ago. We have to study these kinds of structure and adopt them in our latest technologies, latest designs, and also how growing population, how to manage this, ensure water supply. And one side we have a lot of floods, the other side drought, how to manage these things. And green storm water infrastructure is another thing where we can collect water from the roof gardens and other roofs and other things. So coming, and also how to recycle them. Water recycling is equally as our infrastructure, like construction, demolition, waste recycling. So all these we need to take care in our systems in the futuristic thing. Circular economy will be the backbone. Like we have to think how, while constructing, we have to think of how it will be deconstructed and how it will be reused, repurposed or reused, and we have to minimize the waste. So these are all the things which we need to take care when we are designing our structures of future. So, and also some of the other aspects which wastewater collection and sorting, waste to energy. There are a number of waste to energy, a lot of things is there. So some of the CSIR labs are working on how we can, from the waste fuel, how we can oil, how we can use fuel and other things we are working. So some of the collaborations will enable all these things to put in place. And moving forward, we should have floating and vertical cities. Some of them are already existing. So where it is inclusive design, we have to take care for all. And also desalination and other things. One of our laboratories working on it, CSIR and Salt and Marine Research Institute in Bhavnagar, they work on this desalination system with the ecosystems. So climate resilience, as I told, we have to take care of all these aspects: rising sea level, extreme weather, and resource shortage. So floating and ambiguous is climate adaptation. So I'll be skipping some of these things, so repeating some of. Bioengineering is another thing, bio-inspired. So if you look at nature, it will give you solutions. That is what we are trying to do in CSIR, where we are adapting bio-inspired, functionally graded material for enhanced impact resistance for strategic sector. So, say for example, a seed falls from the, like coconut, it falls from a height, but it doesn't get damaged. So if you analyze this section, you'll see how the arrangement it is there, which this seed has adapted itself. So similar way, we are trying to design our panels so that it will be functionally graded to resist the impact resistance. And we are mature to some level, we could create them physically so that enhanced impact resistance is there. So which also saves material as well as ensures safety. So nature inspired, again bio-inspired or nature inspired design, we have to look into many of these things to give a very optimized solution. If you see nature, it is very optimized. Best solution will be from nature. So it will take, if you see any bird or an animal, it will take whatever it requires, not one little more also it will not take. But we humans, we are very greedy, we are not satisfied with whatever we are having. So we try to consume more than what we require. So we have to look into the nature to optimize our solutions. So some of the regenerative structures in other cities we could think in the future, and urban forest, some of skyscrapers already is adopting these things. And so in the summary, if I have to see the benefits, it enhances the quality of life, and also reduce the resource consumption. And we move towards more sustainable future. So we also have a dynamic ecosystem which adapts to the environment. So our focus will be on, as highlighted earlier, sustainability, resilience, adaptability, and also using smart technologies. So in summary, like digital engineering, where it will enhances BIM and GIS plus asset registers, this can be used, and also this can be a passport for traceability and reuse. So some of the traceability is one thing which we never do it, like where this material has originated, all this traceability needs a kind of a passport, which by digital engineering it will be enabled. And SHM again sensors by and IoT gateways will be there, and where we can have a dashboards for compliance as well as for carbon tracking. These are all the things which will enable us to build some sustainability solutions. And simulations, again, it is handy so that we can have these simulations done before we go for implementation. And as highlighted, digital twins for predictive maintenance and residual life, and also retrofit prioritization, where digital engineering will come in hand. So in concluding remarks, I would like to say CAD is not just a tool. It is an ecosystem of intelligence. So future CAD will be faster, smarter, greener, immersive. So, and also we need to train ourselves to co-create with AI and machines. So that is where human and machine interaction is very much essential, and we have to equip ourselves for that. So computer-aided design is no longer just CAD, but it is collaborative, adaptive, and distributive. So I would like to acknowledge the organizers of CAD Summit and also Dr. N. Subramaniam in particular, and Happy Engineers Day, and proud to be an engineer, civil engineer, who is the architect of progress, turning ideas into innovation and challenges into solutions for better tomorrow and a safer tomorrow. So I would like to conclude with the Thirukkural, which goes this way, which means that if there is a clear way of doing things, excel for it. If there are no ways, search for new ways to accomplish your task. With that, I thank everyone for patiently listening, and
I think there was a lot of information which was so relevant, because while we are talking about CAD, if you look at the brand like Green Zone, we have a comprehensive, interior architecture design. We are talking about elevated IoT, which comes under IoT. So thanks for that, and I think you will love to. I know you're very busy, so whenever possible, you would like to find a way to get more inputs, insights from you. Thank you.